This is the story of a white blood cell that finds an infection and goes through the wall of an artery in order to stop that infection. What you see now is called a lipid raft. It's made up of special phospholipids that pack tightly together and hold together the membrane proteins that are specifically linked to that lipid raft. These lipid rafts move around in the phospholipid bilayer and coordinate activity. Now we are zooming down one of the microvilli inside of one of those microvilli protrusions. And what we see now is the polymerization of actin from the actin monomers, and actin forms the cytoskeletal network. This is gelsolin. It cuts off a part of the actin filament. Now we see microtubulin assembling from tubulin monomers, and this is called catastrophe when the microtubules move back. This is kinesin walking along the microtubule and pulling behind it a vesicle. And along this picture you can see a lot of microtubules, all with vesicles being pulled by various motor proteins. And in the center is the centrosome with its centrioles. This is the cell surface, the nucleus surface with the nuclear pores, and mRNA is coming out of the nuclear pores and now is assembling with a spliceosome that allows the mRNA to be processed before the ribosome, which is shown there, begins to read the mRNA and produce a protein. This is another ribosome assembling onto the surface of the endoplasmic reticulum, or the Golgi body, and in this case it's producing a protein that will be secreted. It's contained inside of a vesicle, inside of that membrane coat, and pulled to the outside of the cell by such a motor such as kinesin, which is shown here. And these are vesicles that are being dragged from the Golgi body, which is shown right here, to the outside of the cell, and we're going to watch them being secreted into the space between the membrane and the extracellular matrix, which is above. These proteins are secreted, but they don't leave the membrane because they're bound to the membrane. And these are the proteins, the ICAM, that can reach up and bind tightly to the receptor molecules on a cell that is signaling a problem somewhere behind the cell. Once ICAM binds, it allows the white blood cell to go through a conformational change where the actin matrix dissolves, and it allows it to slither into the region where it needs to eat up the bacteria or the infection. And that's all.